Welcome back, CIS 1400. So you've already hopefully watched the video that demonstrates the foundation of this module and read the text. So I figured with this particular video we get into some simple examples in just Python. And then in the next video we'll do one large example that kind of carries everything together. So for this part we will just simply start with some selection statements, and then the second part of this video we'll do some looping structures. So I'm in PyCharm right now. I'm going to create a new Python file, and I'll call it selection practice. And we'll just do a couple practice problems here to kind of see how things go. So we'll zoom in so you can see it all. Collapse this real quick. All right. So in the first program that I want to show you is a single alternative structure. So I figure with this one we will simply do single alternative. And in this particular practice we'll just do a simple sales problem. So if you achieve a certain amount in sales, that you earn some sort of bonus. So let's say we'll say if you have a $1,500 in sales, so 1,500 in sales earns a bonus. Alright, so we'll kind of get into just the quick little script here on how we can do that. So let's just start building this out, and we'll just do it little bit by little bit, and I'm going to throw comments in where I can, and then we'll take a little piece by little piece. So first of all, I need a sales amount, and I'm going to get that via input. So we'll go float input, enter the sales amount. All right, and then outside of that, I'm going to have a bonus that I'm going to set equal to 0 for now, because I don't have a bonus yet unless I know how much I get in sales. So here's where I ask my question. Questions always start with one of two keywords, if or while. If it's just a single time you need to ask it, then if is probably the way that you want to go. You want to ask the question, and based on the decision, do something one time. So we'll say something like if, and in Python we don't wrap any of our conditions in parentheses like some other languages might do. We just write out the statement after the keyword. If sales is, say, greater than or equal to 1,500, right? And then we wrap it with a colon to end the conditional structure, and you'll notice when I press the return key, it indents it for me. Indentation in Python, if you haven't already figured it out, is extremely important. These indentations will show us what lines of code are part of the conditional block. So here we just have one line of code. We're going to say bonus, we'll say plus equals 500 to increase the bonus value by 500. And then outside of here we'll just do some print statements. So we'll print the sales amount, just to make sure everybody's understanding what it is. So we'll hit quote sales, whoops, and then we will print the bonus. Bounce out there, comma, and then we will print the total of everything, just to make sure we're all in line. And so here we will just print sales plus the bonus. Okay, so let's come through here. We'll run this and execute this real quick just to see what's happening. So if I run it, all right, we'll zoom in on that. I can enter the sales amount. Let's say I enter something like 1725.50, $1,725.50. I hit enter, and now it says what my sales amount is. It says bonus being 500. Notice it was 0, and I did hit my mark, so it increased by 500, and then I printed it. It might make it a little bit more obvious if I do a quick print statement in here and say bonus earned. I'm just going to do a /n real quick to make sure I get an extra line in there. And if I ran it again just to see what was going on, so let's zoom in on this, and we'll type in something like 1,600, and it says I earned my bonus, so you'll see that that prints out. I got my $500 and go through it. Now if I run it again and don't hit the mark, let's say I have $1,200, well, notice the bonus earned print statement doesn't happen. The bonus is still set to 0 because I didn't earn the $500, and it does everything accordingly. So The single alternative is a really nice structure when you just have something to do based on a given condition being true, and if it's false, you just continue on with the program. My program just wants to print out all my values and only give me the bonus if and only if the sales is 1500. So writing it is fairly simple. Okay? These conditional structures, these Boolean operators here, are really going to be useful for you to determine if things are true or false. So if my sales happens to be greater than or equal to 1500, we do these indented statements. If it's not, I just continue on like they never existed. Either way, whether I do them or don't, I come back out here and I run these statements that are left aligned with the rest of my program. So fairly simple structure there. Let's move into a dual alternative structure. So I'm going to comment these out so I don't have to worry about them anymore. Let's see if I remember the shortcut for that. Whoops, that was wrong. Let's comment that out. Where's it at? Code. And we want to comment with line. There we go. All right, so my next example would be a dual alternative example. And in this example, what we want to do is do something, no matter what, based on the answer being true or false. It's going to be two different things that could happen. But we have to pick a path. We have to do something, okay? The previous example, we wanted to print this stuff out regardless, so single alternative worked. But here I might have completely different messages on based upon whether or not the answer to my question is true or false. So in this one, let's do an SAT score example. Okay? We'll say something like, if my SAT score is above 1200, then I get admitted into this particular university, and if it's not, then it says that I'm not admitted. So I might do a quick input for an SAT score. Equals, we'll go int, because it can only be integers, input, enter the SAT score, and then if my SAT score is greater than 1200, okay, I'm going to print you've been admitted. And now, obviously, if I'm not greater than 1200, if I reach 1200 but don't quite exceed it, I want an else. Okay, so this doesn't require any kind of condition. You never would say else SAT less than 1200. That doesn't make any sense whatsoever. The conditional structures only get paired with questions, and questions only ever start with the word if, or in the next example, the word elif. As long as it has the word if in it, you are asking a question and you need a condition to go along with that question. And else is simply what's going to run when this is not true. And so if I don't make that true, I'm going to print you have not been admitted. And then I can end the program. And either way, this is going to run, and it's going to execute one of these two paths, but it cannot execute both, no matter what. So if I save and run, let's zoom in. Let's say I do type in something like 1250, which is obviously greater than 1200. It should print that I've been admitted. Okay, perfect. Let's say I run it, and I enter something like 1100. Okay. Or 1000, I'll do 1100. Obviously not greater than 1200, so it should print that I have not been admitted. Let's say I hit that bubble case and I do 1200 on the nose. What do you think is going to happen? Hopefully you said that it should say that I have not been admitted because it was not strictly greater than 1200 in this particular example, just to show off some of the different conditional operators that we have here. So you have to be greater than, strictly greater than, in order for that to fire off true. Otherwise, it's going to fire off false each time. So that's a dual alternative example. It's a fairly simple example. You have to pick a path no matter what. Obviously, you can have more things that happen inside each block of code, but either way, you're forced to pick an option no matter what you do. Okay? So let's try another one. Let's go with a mutually exclusive example, maybe something from the previous video that you watched with the notes. We'll do something like grades, okay? So we'll do a mutually exclusive and we'll talk about grades. Okay, grades are pretty simple. You understand them pretty well, I'm sure. Now, if you score a 90 or better in a class, then you get an A. If it's a 80 or better, it's a B. If it's a 70 or better, it's a C. A 60 or better, it's a D. And anything less than a 60 would then be considered a failing grade. So first thing we're going to do is calculate and input a grade. So we'll get a grade, or a score we can call it, and we'll translate it to a grade. So we're going to go int input, oops, and that'll just be a percentage. And my idea here is to pick a path. Now, anytime you're dealing with a mutually exclusive event, you kind of have to work things in a very particular order. So you have to work them from either your lowest score up or your highest score down. What you don't want to do is bounce all around, and I can kind of show you why at the end of this and what might happen. So for this, let's start with the highest score up. Anything greater than or equal to a 90 is considered an A. So if my score is greater than or equal to a 90%, I want to print that I've earned an A. Grade, and we'll go is an A. Okay? And we're basically going to use that line of code over and over and over again. So I'm just going to do a quick copy. Now, if it's not greater than a 90 or equal to a 90, if it's not an A, it has a potential for being a B. So we might say something like elif. And this is what gives it the mutually exclusive part, because the elif is a syntax that says, okay, we can run this line of code, and if it's true, we skip everything below it because we hit something to be true, and therefore we are not triggering the other elifs or the other else in that part. So we're going to go score is greater than or equal to 80, and then we can print that we got a B in the course. And we can continue this pattern, elif score is greater than or equal to 70, because if it wasn't a 90, if it wasn't an A, and it wasn't a B, it could be a C. So we got to check to see if my score is now in that range from 70 to 89. So I'm going to print that it was a C. Elif grade or score is greater than or equal to 60. I'm going to print that it was a D. And now this is where people get confused sometimes. Now the only grade left is an F. If I put in anything else, it's a failing grade. So I don't need a condition here. It's the last rung of the ladder. So I just need to make sure that it runs if none of the other ones were true. And just like we did in the dual alternative, the else runs if these conditions above are not true. So here I just need a simple else, and we're going to print that, well, we'll just do the paste, oops, and the grade was an F, okay? So there's my mutually exclusive events. It works very much like a dual alternative. I do have to pick one path and only one path. If the score is greater than 90, then we print an A and we skip everything else below it. If the score's not greater than 90, it may be greater than 80, and if it is, we do this and we skip everything below it, and so on and so forth. So you can kind of see how things are going to work out. If I enter a grade of, say, a 95, you're going to see a grade with A was made. Yes, a 95 is greater than 80. Yes, a 95 is greater than 70 and 60, but since it actually worked here and came out true, all of these other ones are omitted. It's like they never even existed because we got this true. And this elif is just, we only check the condition if the one above it is not true. So we can run it again, and you can start to see that it starts working with something like a 77. So let's zoom in here, 77. And if you're not sure what grade that is, your program should tell you it's not greater than 90. 77 is not greater than 80, but it is greater than 70. And so it's going to print the C, and it's going to skip everything else below it. So I press enter, it tells me it's a C. And that is why it's very important to have things in order for yourself. If I type in anything else, like say 23, well, it's going to run the else because it was not any of these to be true, so it had to be the F. And this is why you have to be very careful with how you organize certain things. For instance, if I were to just take this out and place it simply above this, okay, and I didn't have the right order to these, okay, I run this program again. Let's say I run a 95. Nothing's going to change. It's still an A because this was true. But let's try something like an 83. You know an 83 is supposed to be a B, but in my structure, in my logic, it's not going to be that because we're going to run through this line by line, top to bottom. Is an 83 greater than or equal to 90? No. Is an 83 greater than or equal to 70? Yes, it is, so it's going to print the C and skip everything else below. So if I press enter, it's a C, and that is obviously logically incorrect. So I want to make sure that there is an order to this in some way, shape, or form. Doesn't matter whether or not you go low to high or high to low, just as long as you maintain some sort of order. So you have to make sure that you're doing that appropriately. Okay? So let that digest a second. But make sure you're capable of doing that. Take some time, code this out for yourself, make sure you're okay with you being able to do that. All right? So I'm going to move on to, I'm going to do a simple string example because it doesn't have to be just numbers when we're talking about these things. So let's talk about a quick example dealing with strings. Okay? So far we've done nothing but greater thans, less thans, equal to, so on and so forth. Let's talk about how we can do stuff with other data types than numbers so we can compare strings. Generally we don't think of strings or words being as greater than or less than or greater than or equal to or less than or equal to, but we often think about them either being equal to or not equal to certain things. So maybe we have something like a password that we have to enter in order to get admittance to a program. So let's enter a password. And let's assume the password needs to be the value of correct in order to grant access. So we could say something like if password is equal to, and we always use a double equal sign to check equality between a left and right hand piece. The single equal sign, as you've learned from previous modules, is an assignment statement. It will actually assign what's on the right to the variable on the left. We want to check to see if they are the same. So here I'm going to check to see if the word password is the word correct and spelled in that way. And if it is, we can print access granted. Otherwise, dual alternative, we can print access denied. Okay, so pretty simple program here. Enter a program or enter a password, we'll run it. Here the password's going to be something, maybe I type in the word password, and it's going to say access denied because the word password was not equal to the word correct. If I type in the word correct, and then it says access granted. So there are actually ways to do selection structures with things other than numbers. Okay, we can check equality based on strings, characters, Boolean values, objects when we finally get into them, sets and lists and all sorts of other stuff. So there are lots of ways to go about this. I'm not going to inundate you with all the different keywords that we can use and things like that. We're going to keep it relatively simple for now. But there is a very basic example of a dual alternative using something other than numbers, and for instance here a string. So hopefully that's okay with those types of examples. I'd like to move on to the looping examples to do some while loop and for loop practice in Python. So if you want to open up a brand new program, I think I'm going to do that real quick. So I'll come over to my project. I'm going to open a new Python file for my looping practice. All right. And we'll talk about the two different kinds of loops that we've introduced here in this module, the while loop and the for loop. First, we'll start with a while loop. A while loop is simply a question, again, just like the selection structures, the if statements. But the thing is, with the while loop, the question keeps repetitively getting asked, and you need to find a way to get out of it. So with a while loop, it's all about asking the question, execute the body, then ask the question again. Execute the loop body, ask the question again. So Pretty simple. Maybe it's something like we just want to have some sort of counter, okay, in our program. So I might do something like this, counter. We'll do a count to 10 example. So I might have something like counter equals 1, okay? And now while my counter is less than or equal to 10, okay, I want to print the value of the counter. And then I want to make sure that I increment the counter, because if it doesn't change, then my loop never really ends. So I'm going to do this plus equals 1 here to make sure that the counter keeps changing within the body of the loop. Now this is a really simple program. It just simply prints out this counting message. And what you'll see though is I wrote 4 lines of code and got 10 responses. It counted everything from 1 to 10. I could change this up very easily. Let's say I wanted to count from 10 down to 1. So start the counter at 10, run it while counter is greater than or equal to 1, and instead of increasing the counter each time, decrease the counter each time. So now my loop is now counting down from 10 to 1. So again, fairly simple example of how that can work, yeah, we can keep track of how many times this is going to loop and run and do certain things. Oftentimes we don't think about the while loop as being a counter control loop, more of a fixed repetition. We use it more as a conditional repetition. And so let me give you a quick example of how that might look. So we'll do a conditional repetition, and okay. We'll do it with a pretty easy program. Let's pretend for a sec that you are having a discussion or argument, as you might say, with a 3-year-old. And the only answer they will accept is the word because. And no matter what you do, they're just going to simply ask you why. So we're going to come up with some sort of response to the question. Now, the question really hasn't been asked yet, so and every time you have a while loop, you have to have this loop control variable. There has to be something. Oftentimes it's defaulted to nothing, and so in our case it's going to be a blank string, or if you'd like, you can use the keyword none. They both represent nothing, okay? And I'm going to say while the response is not equal to, if I can spell it the right way, is not equal to the word because, with an exclamation point, like I'm yelling at them. Okay, we're just going to simply do response equals input as to but why. Okay. And then we'll do a quick print finally. So let's just take a look at what this is going to do. Okay, if I were to run this, okay, you're going to see that this question gets asked, but why? Now this question is buried inside the loop. How did we get in there in the first place? Well, it's because I have this value called response, and response was not equal to the word because. Response was equal to this none variable, okay, or this none type. And since this side and this side aren't exactly the same, this is a true statement. Okay, we continue the loop while it's true, and since they're not equal to each other, that's a true statement. So I can ask this question, but why? And as I start typing things in, like why not? It's going to ask me again, because response was why not, and why not is not equal to because. I said so, but why? I need you to, but why? Just 'cause. But why? It doesn't stop until I do things very, very specifically, like the way that I asked. I type in the word because, exclamation point. And now these two response here will match this string over here. And finally, the madness stops, and I'm done speaking with my 3-year-old in whatever conversation we are having that particular day. So that's kind of a really basic conditional repetition example. We'll get into some more finite, or I should say realistic examples in a little bit here when we start focusing on the next problem. but you can kind of at least start to see how this all comes together and how it loops. Okay. Now, either way, you got to be really careful with your looping structures because you could run into issues. Okay, so let's talk about some of those easy to find issues in looping. Okay, so let's come over here and let's assume that we're doing some sort of RPG, role-playing game. Okay, and we have some sort of health, right? And we're going to set our health equal to 10 units. And we have some sort of damage that we can give or take, and the damage is equal to 3 hit points each time. Okay. So let's get into a problem where it's like, while my health is greater than, or I should say, not equal to 0. Okay, which makes sense. If my health ever reaches 0, I should be done with the game, and I'm kind of done here. Okay, so let's just assume we're repetitively taking damage. So we'll go health, yes, health minus equals damage. Okay, and then while that's going, we're going to print taking damage, and then when it's finally overdone, we'll say print game over. Okay, so right now there's a huge issue with this loop. I'm going to invite you to take a second, if you haven't already figured it out, to pause the video, look at it, maybe try to trace it, see what the variables are going to be every execution of this loop, and see what kind of happens, and then we'll talk about how we can fix it. So go ahead, take a minute, pause it if you haven't already figured it out, and we'll come back and talk about the solution in a second. Alright, so if you've already come back, we can start to look at this, and let's run it real quick just to see what happens. And you see that my output is just going insane here. Okay, I've got taking damage, taking damage, taking damage, and this is actually still running. Not something we want, so I'm going to stop it real quick. And it comes up with this error message because I interrupted the program without it actually ending. But why was it never ending? Well, if you think about it here, health is at 10, and health keeps decreasing by damage amount, which is 3. Well, 10 minus 3 makes 7, and if I do it again, 7 minus 3 makes 4, and if I do it again, 4 minus 3 makes 1, still not 0, and then 1 minus 3 makes negative 2, but it's still not equal to 0, so this is still a true statement, and as soon as we keep going, we've completely missed the 0, haven't we? So for looping problems, you want to try to avoid this infinite loop as much as you can. It's really kind of easy to skip and miss, but this would have made a whole lot more sense if we just simply said greater than 0. Okay? And if I were to run this one more time, now you'll see that it only works 4 times. I run it once when my health is 10, run it again when it's 7, 4, and 1, and then finally it becomes something that's less than 0 or equal to 0, and it finally ends, and my loop is over. So one thing when it comes to looping, you need to make sure that it can come out false in some way, shape, or form. So the not equal to's and strictly equal to's, they're good Boolean operators. They're best used for things like strings, okay, to be perfectly honest with you. And your less thans, greater thans, less than or equal to's, and greater than, less than or equal to's are much better conditions to use for values and numbers because you just have a wider arrangement of values that could come out false. And so hopefully you don't run into those issues of those infinite loops. If you do run that infinite loop, just hit the stop key on PyCharm or hit Command or Control C on your keyboard and idle, and that'll kind of end things out too. Okay? So hopefully that kind of clears things up with some common looping mistakes that you need to be aware of. But you should never really have an infinite loop in your programs. Always find a way for them to get out of there. Okay? Now the last one I'm going to look at is the, whoops, didn't mean to take that out, commented out, is the for loop. Okay? So the for loop is a little bit different. The for loop is a sequence control loop. And what that means is that it is going to run a specific number of times for every member, once for every member in a given sequence. Okay? Sequences come in all different shapes and sizes. A string is a sequence. Okay? Let's give you, for instance, my sequence. And I'm going to give you a string of characters, and I'm just going to type out A, B, C, D, E, F, G. Okay? So there's kind of the alphabet. Should make an assignment here. Now, a for loop can iterate over a sequence, pulling out a single member from the sequence one at a time. For loops are pretty simple to write. You start with the word for, and then you give it some sort of control variable, much like we had a control variable up here like health, or response, or counter. Okay? You need some sort of variable. Oops, didn't mean for that to stay there. Put that back up here. Right? So like I've said, the control variable, much like counter or health or response, needs to be there to obtain and hold on to a single member from the sequence during each iteration. So for here, my sequence is a collection of characters, so I might say something like letter. Okay? And then we have to name our sequence along with a Boolean operator. Now I cannot use something like double equal signs or not equal to or greater than or less than, because that doesn't work very well with sequences. I can't say that this letter is greater than my sequence. It just doesn't roll off the tongue very well. But I can say and check to see if the letter is in my sequence. The in operator determines if a certain value is a member of a other sequence. Now I know letter isn't necessarily defined, but letter is going to obtain a value from my sequence, and then we can prove that it is in my sequence. Okay? So we're going to go with the good old colon here, just like always, and then I can enter in my loop body. So I can go for or print. I can go current letter, or we'll go current member of sequence. And then I will print next to it letter. Okay. And so that's all I'll do, and I'm going to print done with loop. Okay. And let's run this, and you'll see that it should print out each line one at a time. Current member of sequence A, then B, then C, then D, E, F, and G. So what happens is my sequence is a sequence of, in our case, characters, a string. And what I can do then is bounce basically each individual member in a letter and then use it appropriately throughout the context of this loop. There are lots and lots of different sequences available to you in any programming language. For us, a string is a sequence. I'm also going to show you how you can get a sequence of digits, a sequence of integers very, very easily. Lists, collections of items are also sequences that you can iterate over. So we'll give you those examples as they kind of come up, but for now we can do all sorts of different sequences. So let's try another one where it's something like this. God, I keep pressing the wrong button there. So command slash, let's try that. Let's do a sequence of numbers. So maybe we'll do a for, and I'll do value in range. Okay. Now the range object, if you can see here, has a couple different arguments that I can place into it. The arguments are the start value, where I want to start, the stop value, where I'd like it to stop, and an incrementation, what I'd like it to kind of increment by. So if I type in, let's say, one value, let's just say a 5. Okay, what I'm basically giving it is a stop value. I want the range function to produce a sequence from 0 to 4. Okay. Zero, 1, 2, 3, 4. Okay. And so you'll see that right here when I go and print it. Print out value. Right? Now if I run this, now you're going to see it's 0, 1, 2, 3, 4. So by putting in a single number, it gives me 5 iterations of my loop each and every time. And the sequence that is actually produced are the values 0 through 4. Okay, if I were to change this a little bit, let me comment that out. And actually, we'll do something like for value in range of 5, 10. Okay, so this is actually going to produce a sequence that looks like this. It's going to start at 5, go to 6, 7, 8, and 9, but it is not going to include 10. The second argument here is now the stop, and notice how in the stop here it didn't actually use the 5, it just produced 0 through 4. This is going to produce everything from 5 up to, but not including 10. And so if I do the same print statement again, and run it, you're going to see I get 5, 6, 7, 8, 9. Right? And I can continue on this pattern pretty easily. So let's say we copy that, comment, and let's do another one. But let's change this so that it's something like, we'll do 0 to 50, but by 2s instead. So you're going to see that this actually produces a sequence starting at 0. Then it's going to go to 2, 4, 6, 8, 10, and so on and so forth, all the way up until it gets to 48. It's going to want to do 50, but 50 is the stop value, and we never include the stop value. So if I go ahead and print this one, you're going to see it gives me the members all the way from 0 all the way down to 48. So the for loop is a really nice loop to kind of help you with some counter-controlled repetition. The range object can help you do that and how you want to go about it. You can start these values off negative if you wish. Let's say I do a negative 10 to 10. All right. Now I get negative 10 up to 8, right? Because I don't include the actual 10. If I wanted to count backwards, I absolutely could do that. Okay, so let's comment that out real quick. Paste, and let's say we wanted to start at, say, 20, count all the way down to 0, and include the 0. So I'm actually going to put something in here like a negative 1, but I want to go down by 2s. The reason I would put in a negative 1 is because if I want the 0 to show up in the list, I have to make sure it's included in the set that's going to be made here. So for us, this set is going to go from 20 down to negative 1, but not include negative 1, by 2. Right? And so I actually get the 0 at the end, which is what I'm looking for there. Okay? So lots of different ways to work with it and do different things. Okay? Some other simple examples might be something like you want to count how many characters are in a sequence. So let's say I do something like my phrase. First, let's comment this stuff out. Whoops, wrong button. So we'll do something like phrase is equal to input, enter a short phrase. And I'd simply want to count how many characters are in it. So let's do this. We'll go for, and I'm going to do letter in phrase. And again, this word is not very important. Okay, you can call it whatever you want or even use a single letter. For a letter in phrase, I want to keep track of some sort of counter. So I'm going to initialize a counter equal to 0. And what I want to do is every time this goes through, just simply increase the counter by 1. Okay. And then I will simply print the number of characters in phrase. And then I can print counter. And what you'll see is what happens is I can enter a short phrase. Okay. And if you think about it, there's 1, 2 for the space. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14 characters here. So when I press enter, it should count them all up, and it prints out exactly how many characters there were in my short phrase. And I can run it with any phrase that I want. Okay? I can say hello world. And there are 11 characters. 1, 2, 3, 4, 5 for hello. 1, 2, 3, 4, 5 for world, plus the space that counts as a character and everything that we have going on here. So this makes it pretty easy to work with. I can even try to combine some of the things that I had going on and try to figure out how many L's there are in the phrase if I really, really wanted to. That could be done by compounding some of these things. So I can do something like this. I can say if, okay, my letter equals an L, okay, increase counter by 1. So now I'm nesting these structures. So I've got this for loop that's going through every part in the phrase, every letter in the phrase, and I'm checking to see if the letter that it comes up with each time is equal to the letter L. And if it is, I can start counting how many there might be. So I wouldn't say the number of characters, but I can say the number of L's in the phrase, and I can print it out. And so if I go back to hello world, we should see that there's 1, 2, 3 L's in hello world, and I can press enter, and then I've got it. There are 3 L's in phrase. So simple examples, I know, pretty easy to mimic and replicate, but each have their intention here. So keep those in mind. Feel free to kind of watch that video again and code out some of these sequences that I've done so that you have those programs to kind of work off of. But overall, the Python structure for looping structures and for for looping structures and repetition structures is not terribly bad. They're actually pretty simple and easy to work through. Okay, so you've got the while loops, you've got the for loops, and then if we came back over to the selection practice, you have your single alternative, your simple if statements, you've got your dual alternative, your if-else structures, and then you've got your mutually exclusive examples with your if, elif, else structures. And then you can do them also with strings or any other kind of data type that you really want, as long as you use the right sort of operation. So hopefully that helps kind of clear things up Python-wise, programming-wise. If you have experience in other languages, they all do it pretty similarly. Some do it a little bit differently. But either way, the idea is still the same. Ask a question, get the answer as a yes-no answer, true-false answer, do something based upon the answer. So hopefully that helps out. In the next video, we're going to kind of pseudocode, flowchart, and code a small program, a guessing game, to make sure that we can see how to pull all these things together into kind of one big idea. So be on the lookout for that. That's coming up next, and go ahead and watch it. And feel free, once you get the program description, to try it on your own first, and then come back and kind of watch and see how things unfold. So we'll see you in the next video. Thanks.